Okay, hello everyone. I just thought I'd do you a quick video on some cracking equations just to make sure you can all understand those instructions on the PDF. Okay, so what you've hopefully learnt so far from that PDF is that long chain hydrocarbons can be broken down into smaller chain hydrocarbons, and the reason why we do this is to make more useful products. Okay, our small alkanes are useful to make fuels, and our alkenes are useful to make plastics. So it's a really important process that they do in industry. Okay, so let's start off with an example. I'm going to go for hexane. Okay, 1, 2, 3, 4, 5, 6. Okay, I'm going to not draw the hydrogens on here just to save a little bit of time and to save some space on this board. I'm going to say that this molecule is cracked. And to crack this, I need temperatures of around 600 to 700 degrees Celsius. Hopefully you picked that up from the PDF. And you'll also need a catalyst. And the catalyst that we use is silicon dioxide, okay, also known as silica, if you've come across that before. Okay, all that's going to happen here is that this molecule is going to break up. Now it can break up into a number of ways. It could break up here, it could break here, it could break here, it could even just break hydrogen off the end, so you will get a mixture of products. Okay, I'm going to choose this to break here. So what I end up with is two products, one that has 2 carbons and one that has 4 carbons. So my number of carbons has to stay the same. I'm not adding any more in, I'm not taking any away. Okay. Now I need to put in the hydrogens. Now in total here I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogens. Okay, so what you might be tempted to do is this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Give them all hydrogens. But what you can see now is that I've managed to add some hydrogens, and that is not allowed. I can't magically add up some hydrogens. So what that tells me is that my products must have a double bond in there somewhere. Okay, so I'm going to say that this smaller one here has the double bond and therefore only has 1, 2, 3, 4 hydrogens, along with the hydrogens that are over here: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That equates to the number of hydrogens that were already there. Okay, so what you can see is I've managed to make an alkene. There's my double bond, and I've managed to make a smaller alkane, which can be used for fuels. There's no way of knowing how a molecule is going to be split up. So in a question they would have to give you a clue. They'd have to tell you how many carbons were in the products. They'd have to talk about the ratio in which those products were formed. So don't worry about, well, how am I supposed to know what it breaks up into? There is going to be a clue there for you. Okay, I'm just going to rewrite this whole equation, but just as the molecular formula instead of the displayed formula. So let me just remove this. Okay, I'm going to stick with the same one. So we're going to stick with hexane. So C6H14. There's my molecular formula. Hopefully we're all familiar with that now. And that splits up into the alkene. So in this case it was ethene, C2H4, and C4H. What's this one going to be now? 10. Okay. Really important at this stage just to check that the number of carbons equals the number of carbons that you started with, as does the number of hydrogens. Okay. Final reminder: the conditions 600, 700 degrees, and a catalyst of silicon. Silicon dioxide. Okay, really typical for questions to look like this. I'll just show you an example. I'm going to pick one off the top of my head. I'm going to go for decane, which is a hydrocarbon with 10 carbons. Using my formula of CnH2n plus 2, I can quickly work out that there are 22 hydrogens. I don't need to draw it all out. Okay, that is going to get split into, I'm going to say C3H6 and something else. So your challenge would be to work out what that something else was. Okay, so what I suggest you do here, say, right, well, if you started off with 10 carbons, you've now got 3, means you must have 7 in that final product. And likewise over here, started off with 22, you've now got 6, so therefore you must have 16 hydrogens left. And what I would do in this case is I'd just check that this matched your molecular formula. Okay, so if this was 7, 2 times 7, 14, plus the 2 is 16, so yes, you can be confident that you've done that correctly. Okay, I'm going to just do one more example. I'm going to choose, let's go for nonane this time, so let's go for C9. H, again using the formula, 2 times 9 is 18 plus 2 is 20. Okay, and this time I'm going to say I get 2 C2H4 plus something else. Okay, so this time it's really important to notice this too, because it means you've got 2 lots of this molecule. So you need to take into that account when you're counting the number of carbons and hydrogens that have been used. Okay, so what I'm going to say is, well, if I started off with 9 carbons here, I've cracked it into a molecule with 2, but 2 of them. So that must mean I have 5 carbons left. 2 times 2 is 4, plus this 5 is 9. Okay, for my hydrogens, I started off with 20, cracked it into a molecule that has 4, but 2 of them, so therefore 8 hydrogens have already been used, which must mean that only 12 are left over. And again, I'll just double check that that fits into my equation, my general formula. When n is 5, h must be 2 times 5 plus 2 is 12. So I can be confident that that one is also correct. Okay, I hope that has made sense to you all. There's plenty of practice on your PDF to have a go at. As always, if you have any questions, please do type them on the chat or get in touch with me and we can go through that again. All right, bye for now.